Okay, so I want you to try a little visualization exercise with me. Imagine a machine.
Oh, this is a good one.
Right, but I don't mean a car or a printing press or even a robot arm on an assembly line. I want you to picture a single colossal engine.
A very big engine.
A machine so big it takes up square miles of desert. And this machine doesn't produce widgets, it doesn't produce
It
smartphones.
produces universities.
Right, it produces entire self-sustaining universities and hospitals and legal clinics.
Which I know sounds completely crazy.
It sounds like the plot of a sci-fi novel, like something out of a utopian manifesto from the 1950s.
It does sound like fiction. I mean, when I first opened this document, I was ready to dismiss it as a total fantasy.
Same here. We're taking you on a deep dive today into something called the Civilization Engine. And when I saw the price tag on this, $20 billion, and the location being the Nevada desert, I thought, okay, here we go. Another billionaire's fever dream.
But then you actually look at the specs, and you look at the math.
That is the thing. On the surface, it looks like a blueprint for a giant factory.
But when you actually read the fine print, you realize it is a blueprint for a completely new economic model. It is proposing a massive shift in how we think about production itself.
We are talking about a fully robotic, vertically integrated industrial complex. But the mission, and this is where it gets really interesting for you as the listener, the mission isn't to maximize shareholder value.
No, the mission is to solve the funding crisis for education, for healthcare, and for legal services.
Permanently.
Permanently. That is a heavy word.
Yeah.
So before we get into the philosophical why of it all, we have to understand the mechanical how.
Because none of this matters if the machine doesn't work.
Exactly. So we are standing in the Nevada desert. What are we actually looking at?
You are looking at a gigafactory, but on a scale that makes most modern factories look quaint. It is a $20 billion facility. But the defining feature isn't just the sheer size, it's the autonomy.
This place is designed to be fully robotic. Fully robotic. And when we say robotic, we don't just mean a few arms welding car doors together.
Right.
We mean the extraction, the processing, the assembly. It is designed to run with almost zero human labor. And crucially, it is designed to be entirely energy independent.
The source material specifically says zero purchased electricity.
Which sounds impossible for a factory of this size. Heavy industry is a massive energy hog.
How do you unplug a steel mill from the grid? That's what I was wondering.
You use the sun. The proposal relies entirely on a massive solar array. But here's the technical detail that really caught my eye. They aren't using standard lithium-ion batteries for storage.
No, they specify LTO storage.
Right, lithium titanate oxide.
Okay, hang on. Why does that specific battery chemistry matter? Why not just use the same batteries that are in our electric cars or laptops?
Because of longevity. Your standard lithium-ion battery degrades after maybe 1,000 charge cycles.
Right, you notice that with your phone after a couple of years.
Exactly. If you are building a civilization engine meant to run for decades, you can't be replacing the battery bank every 3 years. LTO batteries can handle 10, maybe 20,000 cycles.
They are incredibly durable.
So durable. The facility is designed for a 50-year operational lifespan with very little maintenance. It is a generational infrastructure project, not a consumer gadget.
Okay, so we have this solar-powered robotic beast out in the desert. It is humming along, storing power in these heavy-duty batteries. What is it actually churning out? Because the numbers here are hard to wrap your head around.
It was an ocean of material. We are talking about 3 million tons of high-grade steel per year.
That is enough to build multiple Golden Gate bridges every single year?
Easily. But the factory isn't just selling raw steel, it is turning that steel into a finished product, specifically high-rise towers.
The target output is 2,000 steel high-rise towers every single year.
2,000 towers. That is basically building a new Chicago every 12 months.
Which is immense. And the only reason it's feasible is because of that term we touched on earlier, vertical integration.
Right. We hear tech companies toss that term around all the time. Oh, we're vertically integrated.
Which usually just means they own their own delivery trucks.
Yeah, but here it is taken to the absolute extreme. This factory doesn't just weld the steel frames, it produces the glass for the windows.
It manufactures the electronics for the smart home systems.
It builds the MEP modules, that's mechanical, electrical, and plumbing. It even produces the concrete substitute.
I wanted to ask you about that. The proposal mentions ferrock. I have heard of it, but isn't it kind of a niche material?
It is niche, but it fits this model perfectly. Ferrock is a green alternative to traditional concrete.
Mm-hmm.
It is actually made from waste steel dust and silica.
Which this factory would have plenty of.
Tons of it. And unlike concrete, which emits huge amounts of CO2 when it cures, ferrock actually absorbs CO2. It turns into a carbon sink.
So the factory is using its own industrial waste to build the walls of these towers.
Exactly. Every single component needed to build these towers is made in-house. And because the energy is coming from the sun, which is free after you buy the panels, and the labor is robotic,
The cost drops?
it plummets. The proposal uses the phrase near zero marginal cost.
Okay, I have to play the skeptic here for our listeners. Near zero sounds great in a white paper, but we are talking about physical matter. Steel is not free. Glass is not free.
That is very true.
Even if the robots are doing the work, you still have to acquire the raw materials.
Right. Zero is hyperbolic, but near zero in comparison to current market rates is the core argument. If you strip away the profit margin of the mining company, the logistics company, the steel mill, the glass fabricator, the construction union, and the real estate developer.
You are left with just the raw cost of dirt and energy.
Exactly. So let's look at the actual unit being built, the product, because this isn't a low-income housing block.
Far from it. The primary output is a tower. It's an 11-story building. It has 100,000 square feet of sellable area.
And it is completely residential.
Yes. It contains 40 luxury units, and these are massive units, 2,500 square feet each.
So these are very high-end luxury apartments.
Correct, and that is a critical part of the strategy. This engine isn't building cheap housing for the masses, at least not directly. It is building a high-value asset to sell to the wealthy.
Which brings us to the economics.
Yeah.
Because this is where the too good to be true alarm bells started ringing for me. I looked at the cost to build versus the sale price.
It is a striking gap. The proposal claims the internal cost to build one of these towers, including materials, robotics, energy, everything, is $5 million.
$5 million.
$5 million for an 11-story luxury tower. You can barely build a custom single-family home in Los Angeles for $5 million today. How can they possibly justify that number?
It does seem impossibly low until you deconstruct a traditional construction budget. In a $50 million building project right now, how much of that is actual physical material?
Maybe 10 or 15%?
Right. The rest is labor, insurance, land, acquisition, financing costs, and the compounded profit margins of 50 different subcontractors.
And this civilization engine removes the subcontractors entirely.
It removes the subcontractors, it removes the labor, and because it is prefabricated in a controlled factory, it removes weather delays and material waste. The proposal also notes that the $5 million figure is intentionally padded upward. They actually think they can do it for less.
Okay, so let's assume for the sake of the argument that the robots work perfectly and they can build this tower for $5 million, then they turn around and sell it.
They sell it at $500 per square foot.
Which, for a luxury unit of that size, is actually a pretty competitive deal in most major cities.
It's very competitive. So you have a 100,000 square foot tower sold at $500 a foot.
That is $50 million in revenue per tower.
Spending $5 million to make $50 million.
That is a 90% profit margin. In the commercial construction world, getting 10 or 15% is considered a fantastic year. 90% is unheard of for physical buildings.
It is software margins on a hardware product. And that massive margin is the fuel. That is the whole point of this endeavor.
We aren't building these towers just to house people. We are building them to generate cash.
Exactly. So we have the machine. It's essentially printing money. Now we have to look at where that money goes, because this is where we pivot from a highly efficient business plan to the civilization engine.
Let's break down the annual flow for you. We said the factory produces 2,000 towers a year, but they don't sell all of them.
Right, they keep some.
They keep 225 towers internally every year. Those are set aside for the university campuses, which we will get to in a second. That leaves 1,775 towers to be sold to the public.
Okay, I'm going to walk through the math here carefully because the numbers get very big very fast. We are selling 1,775 towers. Each one sells for $50 million.
So 1,775 5 times 50 million.
That equals $88.75 billion in annual revenue.
Nearly $90 billion a year. That puts this single factory up there with the annual revenue of massive global tech companies.
It is huge. But revenue isn't profit. We have to pay the bills to keep the factory running.
And the bills are shockingly low.
The cost to build all 2,000 towers, the ones we sold plus the ones we kept, is $10 billion. Remember, $5 million a pop.
So 88.75 billion coming in. 10 billion going out to pay for the raw materials and operations.
And then the proposal is very strict about sustainability. They immediately take another $11.25 billion and plow it right back into the factory.
Smart. This is for R&D, upgrading the robots, fixing the solar panels. You don't want the golden goose to starve.
Exactly. So you have roughly $21 billion in total costs and reinvestment. You take your $88.75 billion in revenue, subtract the costs, and you are left with a surplus, a pure net profit
of $67.5 billion per year.
Let's just pause on that number for a second. $67.5 billion every single year.
In a normal corporate model, that money is a dividend. That money buys yachts for the board of directors. That money boosts the stock price for shareholders.
Precisely. In 99% of economic models, that surplus becomes private wealth. But in this model, that $67.5 billion is the civilization part of the engine.
That money is the seed capital for society.
The proposal dictates that they use this surplus to build 3 universities every year.
3 brand new campuses. Every single year, they take that $67.5 billion divided by 3 and create an endowment for each campus.
And the size of that endowment is $22.5 billion per campus.
Just to give you some context here, a $22.5 billion endowment is enormous. That puts a brand new Day One university instantly in the same financial league as the most elite Ivy League schools.
Overnight, most top-tier universities spend over a century building an endowment of that size through careful investments and massive alumni donations. This machine just spits out 3 of them a year.
But having the money in the bank is one thing. How they spend it is what makes this self-sustaining forever. They have this perpetual funding rule.
Yes, this is standard endowment management, but applied very rigorously. The rule assumes the endowment is invested broadly in the global market and earns a conservative 5% annual return.
Which is a pretty safe bet over the long-term horizon.
It is. But here's the catch. They don't spend the 5%, they only spend 1%. The other 4% is immediately reinvested back into the main fund.
Why not spend it all to do more good?
Inflation. If you want this school to be completely free forever, literally for centuries, you have to grow the principal pot faster than inflation eats away its buying power.
By reinvesting 4%, the endowment grows exponentially over time.
So they are living entirely off a fraction of the interest.
But because the principal is so huge, $22.5 billion, that tiny 1% slice is still a massive amount of liquid cash.
1% of $22.5 billion is $225 million a year.
That is the annual operating budget for the school, liquid cash every year.
And the proposal breaks down exactly where that goes. $100 million for professor and staff salaries, $125 million for operations, research, and support.
And because that money is mathematically guaranteed by the massive endowment,
They don't need tuition.
They don't need tuition, they don't need government grants, they don't need alumni donations, they are financially sovereign.
That phrase, financially sovereign, is the core of this whole deep dive.
Yeah.
Think about the psychological impact of that. If you're a student, you walk in the door, and you know you will never see a bill.
No student loans, no debt hanging over you for decades.
And if you are a researcher, this is even more profound.
Right.
If you are a scientist at this university, you don't have to spend 40% of your time writing grant applications begging for funding. The funding is already there. You just do the actual work.
And because the university doesn't need to make money, the output of that work fundamentally changes. The proposal mentions specifically that all intellectual property, all IP, is released directly to the public.
This is a radical shift from how things work now.
Yeah.
Usually, if a university lab discovers a new cancer treatment or a better battery technology, the university patents it and licenses it to a pharmaceutical company or a tech giant.
It gets locked behind a corporate paywall.
Right. We discovered the cure and it cost $10,000 a dose.
Exactly. But here, the mission isn't profit. The mission is public good. So if they invent a new malaria drug, the recipe goes online for free.
If they design a better water filter, the blueprints are in the public domain instantly.
It effectively demonetizes innovation.
It creates a feedback loop where the profit from selling luxury towers to the wealthy is converted into knowledge and technology that everyone can use for free.
Let's talk about the physical campuses themselves. We mentioned those 225 internal towers earlier.
Yes, remember the factory keeps some of what it builds. Those towers become the physical campus.
They become the dorms, the faculty housing the labs, the hospitals.
So the housing is also effectively free because the factory built it internally at pure cost.
And it's powered by the same solar tech, so the cost of living for students and faculty is near zero.
It sounds idyllic, almost too perfect. You have engineering schools focused on advanced robotics.
You have medical schools providing at-cost healthcare to the public. You have law schools providing free legal aid.
It is a complete ecosystem. It addresses the three biggest cost centers for a functioning modern society: education, health, and justice.
And it funds them not through taxes, which are always politically difficult.
But through commerce, through selling high-end real estate.
It uses market capitalism to fund a socialist ideal. It is a fascinating hybrid model.
But there is always a but. We have to talk about the elephant in the desert. You cannot just wish a $20 billion robotic factory into existence.
Yeah, you need the startup capital. You need that initial massive spark to start the engine turning.
And $20 billion is a lot of money. It is not something you can just borrow from a local commercial bank.
The proposal has a highly specific plan for this called the Kickstart.
And this is where we move away from engineering and economics into pure sociology. The proposal suggests a democratic funding mechanism, basically crowdfunding on a massive, unprecedented scale.
The numbers they lay out are 10 million people,
10 million individual participants,
each contributing $100 a month.
for a limited time of 24 months, 2 years.
So 10 million people paying $100 a month, that is $1 billion in cash flow coming in every single month.
Over 24 months, that raises $24 billion.
Which covers the $20 billion for building the Gigafactory.
And it leaves $4 billion in the bank for working capital supply chain setup and getting the first couple of campuses running.
And after those 2 years,
The asking stops. The factory is fully built. The solar panels are switched on. The robots boot up. The towers start rolling off the assembly line. The real estate sales begin.
the endowments fill up.
The system becomes completely self-expanding.
It sounds so incredibly simple when you just say the math out loud. Just get 10 million people. But really think about that challenge for a second. 10 million people is roughly the population of Sweden, or the population of Michigan.
It is a massive coordination project.
Trying to get 10 million people to agree on what to eat for lunch is impossible. Trying to get them to agree to send $100 a month to a massive project in the Nevada desert based on a white paper.
That is the big gamble of this whole concept. The technology is already proven. We know how to build advanced robots. We know how to build commercial solar panels.
We know how to manage giant financial endowments.
None of the individual pieces are science fiction.
The fiction is the human cooperation.
The fiction is the belief. The barrier isn't the laws of physics, and honestly, it isn't even the money. $24 billion is a rounding error in the global economy. The real barrier is trust.
Can you find 10 million people who trust the vision enough to actually commit their own money?
It really forces you to look at our society differently. We have the tools today. We have the resources today. We could literally build a machine that spits out free universities and hospitals in perpetuity.
We have the capacity to eliminate scarcity in these critical sectors. The only thing missing is someone pressing the start button.
It is a deeply provocative thought to leave you with.
If the math works, if the technology exists, why aren't we building it? Is it because we truly can't? Or is it because we just haven't figured out how to coordinate ourselves yet?
That is the real question we have to answer.
Something for you to mull over as you go about your day. Thanks for joining us on this deep dive.
Thanks for listening.